Okay, so hi everybody, I'm Shane, that's me there, and the beautiful woman next to me is my wife, Sarah. And though we just got married, we're kind of sad because we registered for an automatic cat feeder and we didn't get it. So we do what any self-respecting American would do, and we go on Amazon and we found exactly what we needed. And the only problem, $89.95, and that's a little bit too much for us. So we do what any self-respecting maker would do, and we start looking online. And we find lots of different designs, and it's almost like shopping for which thing do we want to manufacture. And so we find exactly what we want, and all of the parts are easily 3D printable, and all the other hardware we can get at a store like Swift Hardware. But then we get to the electronics, and there are modules and things that we have to buy, and you have to kind of cobble it together. And so we asked the question, how come this can't be just like printing a 3D printed model? How come we can't just print our circuit board? And so that's where Open Circuit Institute comes in. So Open Circuit Institute is first and foremost a circuit board design repository. And so it's user-submitted content that is all built around a universal set of parts. And the reason why we have to have a universal set of parts is if you think about 3D printing, all you need to start is filament, right? That's the only thing, and then you can make a large diversity of things. Whereas with circuits, you have to have specialized components that can serve special functions. And so if you look online, there's millions and millions and millions of parts. So we've restricted it to about 250 parts. It's the smallest amount of parts that can do the most amount of things. And we took all those parts and we threw them into a library so it's really easy to use and design with. So it's easy to share designs and things like that. We also provide the tools to make the circuits yourself. And the whole tool chain is fully open source. So you can start finding the plans and putting this together today. So there's two of the mills that we built at a workshop just last month with Marchin here. And the bill of material cost for one of these mills is $500, or you can purchase it from Open Circuit Institute as a kit for $750. And the best thing about this is it can pay for itself after just about 20 circuits. That's comparing to if you wanted to buy these circuits from a fabrication house in like China or something along those lines. Open Circuit Institute also has tutorials on how to use the software and videos. Marcin, you want to scooch over a little bit? Yeah. And videos explaining engineering concepts. So where does all the content on the site come from? Well, right now, it's just me. It's kind of a ghost town. Oops. And so the idea is to start engaging with the community, engineers, students at Michigan Tech, and we start having design competitions. So we might have a competition where you design, say, a clock, or something more difficult, like let's design a cell phone. Or maybe it's a free-form competition where you can design whatever you want and upload it. And we incentivize these competitions with tools that engineers might want to use, or something that everybody wants to use. And so after a few of these competitions, what we hope is that the project will start to grow on its own. People will get engaged, start making their own designs, building off other designs, learning from other people's designs. The idea is the whole community can kind of grow together, and it becomes this useful resource for engineers and students, hobbyists, people like that. So fast forward back to Sarah and I. We're happy now that we can utilize the resources on Open Circuit Institute. We can potentially download designs that people have already made, and those designs are often going to be lower cost than commercial solutions. You can also purchase the tools to make the circuits yourself, and you can use the tutorials that we have on the site to make your own designs and then upload them back up onto Open Circuit Institute. So that is Open Circuit Institute in a broad sense. Do you have any questions?
Is there a certain class of circuits that you're starting off with or targeting, and what are there limitations or ceiling?
Yeah, so I say that all the designs use the universal parts list, and that's a bit of a misrepresentation, because I actually don't want to discriminate. Any design you have, you can go ahead and throw it up on there. And so the sky is the limit with what you can put on there. But right now, I'm kind of trying to focus on a little bit more simple circuits that are modular, that might be used and built on, kind of like seed circuits that can be expanded. It's kind of the idea. Yeah. Jake.
Actually, I got a couple questions. So first, is there a way on the site to see the difficulty? I'm really bad with my hands.
Yeah.
Is there a way to see like the difficulty in circuitry? Or maybe a set of basic skills that you would need to complete?
There isn't right now, but that might be something useful to start putting in like the upload form, where you can put like manufacturing difficulty and then just circuit theory difficulty or something along those lines. So that's a good recommendation. And it should be pretty easy to put that in.
And then as a follow-up, what are the most basic skills that you would need to kind of do a simple circuit on OCI?
So you're saying like to manufacture one?
Yeah, if I want to do the most basic plan on the site.
Yeah, so if you were to go through and download, what you'd have to do is basically follow the directions that we have for it's called the CAM software that converts the circuit into tool movements, or G-code. And so the idea will be you have kind of a set of instructions that you just go through and follow. And then you just have to have basic mechanical knowledge in terms of, it's not quite as one-click print as 3D printing. There's multiple steps, like you have milling, and then you have drilling holes. So basic mechanical knowledge, and then in terms of assembling the circuit, you just have to have soldering ability and basic debugging. Yeah. Yep. Yeah.
Have you looked at comparing, say, all the open source electronics firms and their offerings to the universal parts list, like say for SparkFun? How many of their circuits do you think you expect?
I haven't really taken a focused look at it, but I would say, just as a ballpark, around 50 to 60%. I didn't want to put specialized sensors on the parts list, which is what a lot of the boards on SparkFun is, because in terms of stocking that might be, you might only use that one time. And so what I identified are parts that are going to be used a lot. And so that's why I actually have a, what do I want to call it, a user recommended parts list, which is different than the universal parts list. And what that is a spot where someone could say, man, I really love this Wi-Fi chip. I'm going to recommend this, and you put it on there, and then it's a system where you can upvote or downvote things you like, and so you can look at say like DSP modules. It's kind of a far off example. A specific type of module. You go into that category, and you'll see the top recommendations from the community on that. So that's kind of the idea for having the whole picture. The universal parts list is more of the most commonly used. So in terms of SparkFun, yeah, about 50% probably. Yep. You had a question, yep.
Does your printer print the like PCB substrates and then the electrical conductive paths on it also?
Yes, so what happens is you actually buy, it's called copper-clad fiberglass, and so it's a sheet of fiberglass with copper on top of it, and you do isolation routing. So it's actually a milling tool, so you go through and you cut your isolations and drill your holes. So it's subtractive, not additive manufacturing. Gotcha. Yep.
Question, do you have any for sale in your car?
I don't, but I'm working on getting kits together. So if you'd like one, yeah, we can definitely talk about that.
Unlike some people that are ready to buy, can you walk me through the revenue model? So it's the machine that you're buying that creates the circuits, or
Yep.
is there like individual circuit components? Like if I did want my automatic cat feeder, that I could
Yep.
just come to you and buy this circuit and then set it up with my 3D model.
So we're not quite to that level in terms of buying the circuits. The things that is you start having kits for popular circuits on the site. So say the cat feeder had 10,000 downloads. Something that I might look at is say, oh, I should just start selling maybe selling the board that's already been manufactured and the parts. So you don't have to buy the mill. You can just order the parts and assemble it. Is something that I look into kind of once we start getting a little bit bigger. Does that make sense?
It does. So the main purpose is just the mills right now. You're trying to get people to buy the mills.
Yeah. The biggest thing is to start folks. So the kind of the path to market, as Jason would want me to say, is to really start with the people who are already wanting to do this. Like to start making and assembling their own circuits, and then afterwards, as we kind of start to grow, focusing on people that are less skilled in that just want the end product. Is the idea? Yep. Yeah.
So my question was, your target market, and how are you planning to market how are you planning to reach your market?
Yeah, so something that I want to do is just start locally with like Michigan Tech, and maybe this year have a competition just with the students. And so that's just going to be pinning things on, pin boards and all that stuff, and maybe ask some professors to make a comment in class. And then afterwards, something that I did just a small experiment with is targeted Facebook ads. And so Facebook ads are really nice in terms of saying, I want someone who's an engineer, interested in open source, and Facebook and its crazy algorithm will be able to identify those people and advertise to them. So that's the objective in terms of getting people to contribute. And then so the way I see it, once there's actual content on the site, then you can start to market the mill more, because the website is kind of a good marketing asset for the mill itself. You say, hey, look at this mill, it costs this much, and with it, you can make all these circuits that are already on the site. So with the mill, you're getting, well, even without the mill, you still get access to all the circuits. Does that make sense? Yeah. Jason.
Now, how are you setting up your business? Is this going to be a nonprofit? Is this for like an LLC?
Yeah, I haven't quite determined that, but it'll probably be nonprofit.
Because on that note, one thing that we found out recently is even like Google Ads, they actually provide a certain amount of free ads for nonprofits, like so much per month. And so things we are going to promote it. So there's actually some things we can take advantage of. They
Sure.
promote both the circuits. This is something I just realized I've been hanging onto this from you.
Yeah. Okay. No, that's good to know. Thank you.
It's 10,000 per month.
10,000 per month?
$10,000
Per month, yeah.
Really?
It is.
Dang. Okay.
There are some other qualifications you have to meet.
Sure.
Google has a list of like.
Oh no,
Yeah,
that is.
some grants in the area that people, like the Humane Society, had one for a little while, and yeah, they're out there.
Cool. That's good to know. Thank you. Yes.
Going to your cat feeder example, just if you could walk me through where your role steps in. So if I wanted to make a circuit that hasn't been made yet,
Yeah.
do I still use a software that lets me do a schematic and a board design, or are you stepping in at that level already with software?
So kind of where we'd step in is say you found all the mechanical parts, and then you say you find like the board for the feeder that was like an Arduino and it had a module on top of it. So you could figure out what was on those, and then you would start using Open Circuit Institute's resources. So we use a software called KiCad, which is also free and open source, to design the circuit. And so you'd bring in the Universal Parts List library, and so you'd essentially just be able to drag and drop your parts. And the nice thing is they're already fully defined, so like you have to worry about the dimensions of the parts and all that stuff. I've already gone through and defined all that, so it really kind of can streamline. And then after you've figured out how your circuit's going to work, then you do the circuit board layout. After you do the circuit board layout, then you can use the mill to cut it out, and then obviously assembly and testing. And so kind of a more targeted marketing, I guess, more on your question is or something I've thought about is looking at designs like on the 3D printing website Thingiverse, is just designing the circuit board for something and putting a link, say, hey, I designed this into an integrated circuit, and here it is right there. But anyway, so to answer your question, that's kind of the flow that you go through.
And then to follow it up, have you looked at perhaps I know you talked about the college competition to bring in resources, but what about the high school level? The high school robotics level, where there's a lot of programs now that are bringing the 3D printers into high school for education aspects. What about bringing this milling operation, which is oftentimes a limiting end of not having the ability to create a circuit
Sure.
beyond the breadboard in the high school setting, and using grants to bring that into a K-12 if you do stay nonprofit?
That would be awesome. So I haven't considered quite at that level, just because with high schoolers there would be a little bit more of an education aspect in order to get students really to the point where they can utilize this well. Besides for manufacturing circuits that already exist, that's totally feasible. So I guess once again, that's something that I can consider, and thank you for the recommendation. Yeah.
I guess one source to look at for you for funding on that end, with the 3D printers, Square One Education Network has funded workshops for teachers. So the teachers go, they build the printer, and then the teachers bring it back to the classroom to determine how do I use the education end.
Sure.
You don't have to worry about that.
Yeah.
You have to worry about your device, which is what you want to specialize in anyways.
Yeah, so actually sitting in the audience right there, Dr. Pierce, he has considerable experience doing that in the UP with 3D printers. So I mean, pretty much the entire UP has our printers all over the place. And so expanding that model to something that Marcin works with, he's from Open Source Ecology, is called the, what is it, the microfactory? Yep. So the microfactory, so these are two parts to the microfactory where you can, with a circuit mill and a 3D printer, you're pretty much unstoppable in terms of the things that you can make. So yeah, so integrating that into high schools would be great. Cool. Any more questions? Yeah.
Can you talk about the cost comparison to industry standards?
Yeah, so if you look at a lot of the mills that you'll buy, a lot of popular ones, the $500 bill of material cost is about a quarter the cost of any of the other mills that you'll find online. So having an open source is, and just the design itself, 3D printable parts make it significantly cheaper than other mills that you'll find online. Yeah. Yes?
So other than content, what else do you need?
What else do I need? Well, having some incentives for prizes would be great. So something to put up to start having competitions. And then, well, spots to advertise, people to be engaged in the community is what I'm really looking for.
So what does that look like?
So that looks like students and hobbyists that even, so there's a forum, so even like questions like, hey, I'm working on this design and I don't understand that, and I'd be tickled pink to be able to start responding to those questions and helping out and building a community that way. Yeah. Yep. All right, thank you all very much.
All right, thanks.
Yeah.